In the next two lectures, we'll look at the dynamic nature of JavaScript objects. JS lets you add or remove properties from objects on the fly, which offers remarkable flexibility and design opportunities. We'll also look at the special arguments object, and as usual along the way we'll look at a few other interesting JavaScript features. We've already seen in prior lectures that we can attach new properties to existing objects, including those from the JavaScript libraries. We tried this when talking about wrapper objects in the mastermind example. But the idea that an object can change its spots, getting or losing properties after construction, takes some getting used to if you're a traditional OO programmer, so we're going to spend a bit of time showing its possibilities. Our example slide has several anonymous function calls, here and so on, each illustrating various dynamic object ideas. We use the built-in wrapper objects and their constructors as our starting point in each of them, adjusting or adding to them, but the principles involved apply to any objects and constructors. We'll start with a review of the wrapper object concepts and with adding data properties to the wrappers, and then we'll add function properties to them, and finally we'll add a function property to a constructor. And we already know from earlier discussion that JS creates temporary wrapper objects when we use an elemental type as an object. You can also create permanent wrapper objects using new and the wrapper object constructors string, number, and boolean. The function call on lines 1 through 13 here starts by setting up two string variables and then two capital S string objects. Sets up two string variables and then a string object, using the string constructor, which takes a parameter for the string content of the wrapper object that it constructs. Now, line 5 introduces the type of operator, which you can apply to a variable, any variable, to determine what type it is, one of the elementals, an object, or a function. And as you can see from the output down here, S1 is a string elemental, while S3 is an object, a wrapper object. Now, unfortunately, typeof doesn't show what constructor, if any, was used to create the object, so we can't tell that it's a string object. It just indicates that it's an object. The code then does 4 comparisons. Does 4 comparisons on lines 6 through 9 here. Equality comparisons between the various strings and string object. Now, despite the fact that in every case we're comparing effectively equal things, as we can see down in the output, the first two are true, but the latter two are false. So, why? Why would S3 not equal S1, for instance? They're both ABC, right? And if they're not equal, then why are S3 and S4 on the line above equal? Coming back from a pause there. What you should come up with here is the same kind of answer we did in the overview lecture. A wrapper object is created for S1 here. And it's a different object, though with the same content, as that referred to by S3. An equality comparison between object references is shallow. They must refer to exactly the same object, as S3 and S4 do by virtue of the assignment on line 3, in order to be equal. Referring to different objects with the same content won't cut it. And that's also why line 9 is false. Now, if that answer was obvious to you, good. If not, review it carefully. The distinction between shallow and deep comparison comes up in many different languages and will be the source of bad bugs if you don't understand it clearly. So moving on here, lines 11 and 12 assign a property to S1 and S3, a tag property. But here's our second question. In the output, why does S1 tag show as undefined, while S3 tag shows as 42? The output of line 12 here. So think about that. Coming back from pause, This is the same answer as when we discussed this in the overview lecture. The s1.tag expression creates a temporary wrapper for s1, which wrapper gets the property, but then vanishes at the end of the statement. And it's a new wrapper being queried for property tag on line 12, and so it's undefined. The permanent wrapper object S3, however, retains its property. Now, we create a new property on an object by just assigning into it, but removing an existing property requires a special operator, delete. On line 13, we use this operator to remove the tag property from S3, and line 14's output shows that it was deleted right there. But line 14 also illustrates a trick often used with OR and AND operators in JavaScript. And that's this expression here. These operators have the usual logical meaning, but two different JavaScript features conspire to make them work as expressions that let you specify a value and a default alternative of sorts. First, recall that everything in JS has a logical significance, and recall that nan, undefined, zero, empty string, and null are all falsy. And then second, recall the concept of short-circuited and short-circuited OR from your prior language study, in either C or Java, for instance. And if you don't recall, or weren't taught this concept, well, you're not alone, so here's a quick overview. Consider this AND test. If the first part of the test, x less than 10, is false, then could you predict the outcome even if you didn't know the second part? Coming back from a pause, think about that. Yeah, you can predict the outcome. If the first part is false, then the AND is doomed to be false, regardless of the truth or falsity of the second part. So in light of this, it makes sense not even to evaluate the second part if the first part is false. Why waste the time? In almost all programming languages, the second half of an AND is skipped entirely if the first half is false. This is termed a short-circuited AND, or synonymously a protected AND, or a conditional AND. And this rule can save you from runtime errors. Consider, as shown in the notes, an if statement with x not equal to null and x data equal y. If that first test is false, that means x is null, and doing the second test would cause a runtime fault. And short-circuiting avoids this by skipping the second test altogether. There is a similar rule regarding OR. If you've learned it, then remind yourself of it. If not, try to reason it out. Question 4. Is there any circumstance in which we can ignore the second part of an OR based on the outcome of the first part? And coming back from a pause there. Yeah, if the first part is true, then the OR is sure to succeed, and the second part is moot in that case and can be ignored. And of course, this is called a protected, short-circuited, or conditional OR. When JavaScript evaluates a AND or an OR, it doesn't return true or false. Instead, it returns the actual value, Boolean or otherwise, of the first test, if short-circuiting occurs, or the value of the second test otherwise. In other words, it returns the part whose truth or falsity was the determining factor for the entire AND or OR. So, for instance, x equals y or z assigns y into x if y is truthy and the second part is to be ignored. Otherwise, it assigns z into x. For instance, if y is undefined, then it uses z instead, because undefined is falsy. You can read it as use y if y is truthy, otherwise default to z. This idiom appears often in JavaScript code. Okay, but question 5. How can AND or OR work in a test if they aren't returning Boolean and instead are doing this little value choosing thing? What if I write if y double OR z? I don't want values, I just want true or false. Why is this not a problem? Coming back from a pause, you are going to get truth or falsity, or at least truthiness or falsiness, since all values have Boolean significance. So even if these operators return a non-Boolean value, the non-Boolean value still has truthiness or falsiness that reflects the truth or falsity of the entire expression. And you can still use it as a valid test with the same result as if it returned a true or false like it would in a more conventional language. You get the best of both worlds from this values are Booleans deal, combined with short-circuiting. You can use OR either for normal testing or for value defaulting assignments. The OR on line 14 produces the value of s3.tag if that is not undefined. Otherwise, it produces deleted. That's how we got the deleted output. Question 6. Okay, so what use would there be for AND in a value-choosing context as opposed to a testing context? What, for instance, does this accomplish? Down here. Pause and think about that for a little bit. And coming back from a pause there, this checks that x.tag basically exists. It checks that it's not undefined and that it's not null either before proceeding to the second half. If x.tag is falsy, then it returns just the first half and you get a falsy outcome, but you don't get a runtime error by trying to get the subtag property of an undefined or null x.tag. If x.tag is true, then it does proceed to the second half and you actually get x.tag.subtag from the expression. The most common use of double ampersand in assignments like this is to do this level-by-level checking, where you avoid a runtime fault by not descending past a null or undefined reference.